Well, let's go direct to about pollen analysis. We will explain everything and we will do the live demo. Well, this is the main interface of our app. So now we will explain about pollen analysis. What is so important? Why the pollen analysis is so important in the industry? Because it helps you to classify correctly your honey for botanical origin and geographical origin. It is a good tool to use. Also, it helps you to measure quality and purity, how concentrated the honey it is. Also, it provides you with know-how about where the hives are placed. As beekeeper, you can learn how to place better your beehives depending on the results of the pollen analysis, and also to decide when to extract the honey based on blooming, depending on the species that you have. Also for honey packers, when you have to mix different types of honeys. So the pollen analysis helps you to identify the best mixing criteria. We will show you the intelligent calculator that we have for honey packers. Also, to better control your product, not only at the beginning of the process, but during the process and at the end. And also because during the pollen analysis, we also can identify other particles, not only pollen. We can see a lot of other microorganisms, other particles. So in the pollen analysis, we will provide you with a lot of information. And now Asma will present you how the sample preparation and how the analysis is done. So it will be my colleague Asma. She's Melissa Palynology, and she will speak now. Hello, Asma.
Hello,
Feel free
good
to
morning. Everyone can hear me well? You can hear me, I hope, just to confirm that the sound is good.
Yeah, it's perfect.
Okay.
Asma. We can hear you, and we can.
I'm Asma. Okay. So my name is Asma, as Erachi already introduced me. I'm the responsible of the Melissopalynology section and the creation of pollen dataset. So I'll briefly explain how the sample is prepared. It's very simple to collect. It requires only basic materials. Anyone can do it. It's not necessary to be an expert. You just have to follow the steps. So we're starting by weighing the honey. But before to weigh, you have to just mix it well, and then add the water, dissolve the solution completely. You have to confirm that the solution is very well dissolved, and then centrifuge for 10 minutes at 3000 ppm. With the 25 microliters of glycerinated water. And finally, place the drop on the slide, cover it with the cover slide, and that's all. The sample is ready for analysis. However, there are some small variations depending on the type of honey. So when the honey is very dirty, for instance, it's necessary to use acidulated water to clean it, to obtain more visible pollen. This is a tip that we use usually when we know that the honey is dirty and it has deep braids. But if the honey if the honey has a high content of pollen, it's better to use a rectangular cover slip, not the small one, just to avoid accumulation of pollen grains. But if the honey has a few pollen grains, it's preferable to use the square cover slip. Another important point is when the honey has a very little pollen, such, for example, let's say acacia honey, it's better to increase the amount of honey used at the beginning. So instead of using 10 grams, let's use, for instance, 20 grams up to 30 grams sometimes. And as you know, we usually don't use any gelatin to fix the samples. So we just put directly the drop over the slide, and that's all. But since some of our collaborators and clients do that, so we have created a specific data set and model based on fixed samples. is a very good option for those who fix the sample. And finally, you have to keep in mind that in some cases, depending on the type of honey or the type of pollen, we reduce the centrifugation speed, use less than 3000 RPM, just to prevent the grain from breaking, because it happens sometimes with big and grains that has a lot of apertures, like rosmarinus pollen, for instance. So don't worry, on our website we have a tutorial showing all the steps and sample preparation protocols. You can find that on our web. So after having the slide prepared, we place it in the microscope, and the analysis begins by scanning. Scanning, as you can see here in the video, it scans along the X, Y, and Z axis with object of course. You can see here how it is focusing on the pollen. In the video, I think you can see that well. So the analysis can take between 15 to 90, depending on the sample, if it has a lot of pollen. So it takes less time than samples that has few pollen. During this process, the system scans the slide in lines, jumping randomly and searching for pollen grains until the entire slide is covered. Then the images are automatically uploaded to the cloud, where the models and algorithms process them, depending on the model we use in the beginning. The system recognizes the pollen, or identify the pollen grains and other elements as well, because we don't only identify the pollen, as you know. We also identify other elements and parts also. And finally, the results are generated and sent in PDF. For the analysis to be completed, the following criteria must be met. At least 500 pollen grains in total. A minimum of 400 nectariferous is counted, and at least 100 fields of view and minimum of 5 lines scanned. There is also an option to stop the analysis earlier, but this is, of course, under the user's responsibility. So far, HoneyAI identify more than 100 species. In the list of this is the list of nectariferous species. There are still some pollen types that are not fully trained. They are trained, but we still need some to continue expanding the data set to be like fully trained. However, with the current data set, I would say that we can cover most of the common European honeys. So this is very good point so far. Here, this is the list of polliniferous species, which is also very important for the counting, as you know. Sometimes we find some disagreements regarding the classification of pollen in terms of aperture value. I think this problem can face a lot of labs, but for this reason we have contact with International Honey Commission that are working now to find consensus on the classification of pollen species. I would say, for instance, some pollen grains in Spain, let's say, are considered nectariferous. Can you hear me? Yes, okay.
Yes,
so I was saying that some nectariferous some pollens are considered nectariferous in Spain, for instance, but in other countries are considered non-nectariferous or polliniferous. But to reach a consensus about that. And currently we are collaborating with research scientists to train models and expand our data set, pollen identification for two new regions, such as Chile and Emirates. And of course, in this kind of collaborations, it's essential to have melissopollinologists to properly identify the pollen grains and avoid confusions. We are always open to collaborations. It's very simple. We have just to send you the microscope, you perform the tests, and we say save and process the images, identify the pollen, and creating the model. Okay, that would be all from my side. If you have any questions about this, you can just write on chat or raise the hand. So that's all. Thank you.
Thank you. Thank you, Asma. Hope everything was clear. If you have questions, just write it in the chat, and at the end of the session, Edu, Asma, or myself will answer all of them. Well, let's go to the PDF of results. Let's understand how we provide you with the results, which kind of information you can find after the analysis that Asma explained. Here I have included this link. This link goes directly to our website. I don't want to open it now, but just to show that if you go to our website and you go to Technology tab and you choose pollen analysis and you do scroll down, you will see exactly what I'm going to show now. You will see an interactive image of the PDF of results, and you can go just surfing in the image, and you will directly see the explanation of each information that we cover. So for instance, you will see which range of yeast we use, which range of starch we use. You will see all the information there. So after the webinar, if you want to go to our website and check this information, you can see everything there. Okay, so I will go step by step explaining the information. When you use our system, you can choose if you have a monofloral honey, and in case that you want to analyze a monofloral honey, you can indicate. If you have a honey that is not monofloral, just include that is a polyfloral, no problem. But if you have a monofloral, indicate here, because then you will have information below. Then also region, this is very important. We have different models for different regions. So if you know which is the geographical origin of your sample, you can choose which model you want to use, because this means that it's going to be more accurate even. This doesn't mean that if you doesn't know exactly which is the origin, you cannot use it. No, there is one model that is called global, that is used when you have no idea when the sample comes from, or when it is a mix of different origins. But if you're analyzing, for instance, one honey coming from Portugal, then choose this model, because it's going to be more accurate. And then also you can use our screening of fraud, let's say. Okay, I will explain later. Then analysis time. It tells you how long was the analysis. As Asma already explained, the analysis time depends on your honey. If it's more concentrated in pollen, then it will finalize earlier. If it's low concentrated, it will take more time. Okay, it's between 15 minutes and hour and a half. Yeast concentration, this is very important. You will receive an estimation of the yeast concentration of your honey. Here, the yeast concentration is dead and alive, both. We always say in the observations panel at the end that if the yeast concentration is medium, high, and you have high moisture, like above 17%, and the honey is not pasteurized, then send it to the lab for further analysis, because you can have problems when packing. Okay, high moisture, high yeast concentration, this is a risk when packing. Otherwise, it's just information. It could be also very useful, because if you see a high concentration of yeast, it could be related to different type of feeding supplements to beehives. It's not good to have a high concentration of yeast, because it could be residues of different feeding complements. Pollen richness, this is very important. With the pollen richness, we can classify with Mauricio levels, ranges, which honey you have. It tells you the amount of pollen grains that you have in your sample. So it tells you how concentrated or pure it is, but it also depends on the type of monoflora that you are analyzing. For the starch content, this is also very important. The starch content should be always below 10% compared to pollen grains. we always include a warning message in the panel of observation if the starch content is above 15%, okay? Because it can be related somehow with bad practices when feeding the beehives, and also dilution with some syrups. So it's not normal if you have starch content about 15, 20%, okay? Then also we can analyze with during the pollen analysis, the honeydew elements. So for honeydew honeys, this is very important. Based on literature, the ratio of honeydew elements divided by nectariferous gland ratio, it should be above 3. So 3 times more honeydew elements, if you have a honeydew honey, than pollen grains. But this is just literature. For instance, in Spain, if you have a dry weather, like in Spain or other countries that are in the south of Europe, it has been demonstrated that the ratio of 3 is too high. We have very good honeydew honeys that the ratio is 1 or 1.5, okay? Then here you can see the total number of pollen grains counted. In this case, this is much more than a human. I don't think that a human is able to count 2,000 pollen grains. This is because we have 3 different criteria: pollen grains counted, nectariferous grains counted, and number of fields. So because we cover at least 100 fields, if the honey has like very rich concentration of pollen grains, at the end, we have scanned an area with a lot of pollen grains. This is very accurate, much more than a human counting, because this is a machine. Also, the number of nectariferous pollen grains. It happens sometimes that you have a lot of pollen grains content, but there is a lot of polliniferous pollen grains. So until we don't reach 400 nectariferous pollen grains, the system continues. That's why we include this information. And then in case that you indicated that your honey is monofloral, here you have the specific concentration, like the relative distribution of that species in the sample. Why we have 2 different values? You always have to check the one that is in black type, because it is the concentration when you eliminate the polliniferous species. So when you have removed those species that are polliniferous, only with the nectariferous species. Then also, in parentheses, you have the relative distribution for the total amount. Okay, you have also information of all pollen spectra. It means that here you have the specific distribution also for other nectariferous plants. Here we include in different ranges, but in the PDF we also include the specific concentration of all the nectariferous species above 9% of concentration. Below 9%, we don't include the specific concentration, but you can find them here. Also, order by frequency. And then we also include the nectarless species if they are above 3%. Otherwise, we don't show them. In observations, this is very, very important, because here you have the direct link to our website where we explain this PDF, as I said before, with interactive map. And also we have here the explanation about the nectariferous, polliniferous, and everything. If the sample is too dirty, it's not clear, we include here an observation, so you can redo again the analysis with acidulated water. And also, because we know that some labs do this, for instance, QSI, we know that they use this correction with overrepresentation. We also have included, in case of a honey that has a high concentration of overrepresented pollen like echium or castanea, you have which would be the value of the target species, for instance, sunflower, if you remove echium and castanea from the counting. Some laboratories, if they consider that the pollen is overrepresented, they consider that it's not nectariferous, but polliniferous. So they remove from the counting echium and castanea, they consider to be contaminants, So the value of relative distribution increases. From HoneyAI, we consider that this practice is not correct. This is our criteria. We consider that they are nectariferous and they should be counted. But again, because at the end is based on the organoleptic and we cannot do the organoleptic with a microscope, in case that the client considered based on the organoleptic that this is the value that should be taken into account, we provide also the client with this value. So as a summary, which information you have in our PDF in 1 hour, 12 euros. You have the complete pollen spectrum with nectariferous, polliniferous, and specific indications. Also the pollen richness. Our accuracy is very good, very accurate. We already demonstrated that with a ring test done with International Honey Commission with other labs. Then the honeydew elements. You have the information about starch, yeast. You have indications in the observations panel in case that they are not normal. You will receive an observation just in the observations panel. Then we have observations for monoflorals or only in Spain available if you have IGPs or DOPs, specific monofloral honeys, and then the data corrected for overrepresentation. And the most important part, our results also include real images of your analysis. This is very important because you can directly check if our analysis was correct or not. I mean, if we say that there is a lot of starch, a lot of yeast, a lot of honeydew, that the pollen richness was low, was high, in case that you want to label your honey as rosmarinos, but our system says that there's no rosmarinos, go and check. You see here real images. So I think that this is a very good point that we provide the user that external laboratories don't do. And here, this is one feature that we have just released in summer for the Iberian Peninsula, available in Spain and Portugal. Already in the supermarkets, we launched with Avijuis, one Spanish brand. You can scan this QR. It is real. For those that you have your mobile phone here, just scan the QR code and you will see what the consumer can see. When you as a client analyze the honey, you finalize the pollen analysis. If you if you do the checkbox when in the APP when doing the analysis, together with the PDF of results, you will also receive a file with a QR code. You can print this QR code in the label, as you can see in the video of Avijuis. So the consumers can scan the QR code and they can learn with very easy to understand information, the commercial information of your brand, marketing first, then information about what melisopollinology is, why pollen is so important, which type of monofloral honey you're about to taste, information about different organoleptic properties of this honey as a monofloral, also real data and real pictures of this pollen in this jar. So in this jar, real pictures of that pollen and real information of the results. And then we include the information about geographical origin. So if in the label it says that is honey coming from Spain, okay, what HoneyAI thinks? It is from Spain or not? Can we confirm that all the pollen grains found are okay with this geographical origin or not? So the consumer can be secure about what they are buying. So we launched in the summer and we have other clients that they have already engaged with this feature. And soon we hope that we can have more. Okay, which is the fraud screening that we can do? I say screening because we never say that we are a fraud detection method. We are a fraud screening method. We only have a system that is very cheap, very affordable. You do it on your own, and it's 12 euros. We cannot do magic. But we have a fraud screening that in geographical, what I said, if you're going to analyze a sample that you know that comes from Spain, or it should comes from Spain, and you use the model from Iberian Peninsula, at the end of the analysis, if the AI think that this honey is suspicious because it has a high percentage of pollen that we cannot recognize, or that the AI doesn't feel comfortable, secure about this type of species, then you will receive a message that it tells you, please send this message to the lab. This honey is suspicious. Send it to a specialized lab where they can really analyze for fraud. One thing that we have implemented, as said, this device is intended for non-lab users. It means that everybody can use our system. It means that sample preparation cannot be good. Okay, we have just implemented a check for quality. So if the sample preparation is not correct, we will not provide the results. This is a equipment for laboratory. So if the sample preparation is not good, if they are too dirt and focused, if you have a lot of pollen clustered, if there are a lot of noises, if there are bubbles, if we consider that the sample is not good, then we will tell the user that they have to redo the sample. Here you can see examples of fields that our microscope automatically dismisses. So if the honey detects that this field is not able to be read, it just dismisses and goes to another. But if during the analysis our system identifies that there is high concentration of non-valid fields, it will stop the analysis and it will tell the user to redo. This is not correct. It means that the system is not able to read. So we will ask the user to dilute more or to use another type of cover slip. This is not able even for a human. So this was for honey analysis, but our system also works with bee pollen. In the case that you want to analyze bee pollen for pollination services analysis, for studies in the field, to know exactly where your bees are going, or because you are selling bee pollen as a honey packer, as a bee pollen packer, you also can use the system for bee pollen. In this case, it's easier because you don't have to centrifuge. You only collect 1 gram of different pellets, random, then you dilute, and then you do the same. You analyze with the square cover slip, and then the system will tell you which are the species and the concentration that we have found. No nectariferous, no polliniferous, just the species. Here you can see a very nice and clear pictures for a sample of bee pollen.